Alright guys, today we're going to be working with some more trig identities. Today our goal is going to be to use what we know about algebra to help us simplify some trigonometric expressions. And really today that's going to focus on factoring and on reducing fractions. There are a couple factoring patterns that are going to be especially helpful for us, so I'd like you to recall for the difference of two squares, this factors into the first term square root plus the sum of the second term square root times the quantity of the square root of the first term minus the square root of the second term. And if you want to confirm this, you can multiply this out and return to the initial expression. The other type of factoring pattern I'd like you to recall is for perfect squares, where for a perfect square in trinomial form we have whatever the first term is squared, whatever the second term of the binomial is squared, and the linear term, that is the term with an x not an x squared, is going to be twice the product of the first and last terms. Let's begin by reminding you about factoring by grouping. Factoring by grouping is the process by which we undistribute something. We look to see what the terms have in common, and then we factor that out. In the case of our pure algebraic one, we have a 3x squared plus 9x. Both of these have a term that's divisible by 3. So there's going to be a 3 on the outside of this distributed part. Both of them also have an x component to the term. If I divide 3x squared by x, so if I pull a 3x out of 3x squared, I'm left with just an x. If I pull a 3x out of a 9x, I'm left with a 3. You can verify this by distributing through. 3x times x is 3x squared. 3x times 3 is a 9x. We can do the same thing with trigonometric functions. In my expression down below, cotangent squared of x minus cotangent squared of x times cosine squared of x, we can see that each of these terms has a cotangent squared portion. What I'm going to do is undistribute this cotangent squared. So I'm left with that on the outside. That's cotangent squared of x equals, to get to cotangent squared by multiplying, and by an equals I mean parentheses, we're going to have a 1 minus factoring a cotangent squared at a cotangent squared cosine squared gives me a cosine squared x. Where this becomes useful is being to recognize some of our identities. 1 minus cosine squared of x. Using our Pythagorean identities, we can say equals sine squared of x. We also know that cotangent of x is cosine over sine. So cotangent squared of x equals cosine squared of x divided by sine squared of x. When we multiply these two, we can cancel the sine squared of x to 1, and we're left with cosine squared of x. Sometimes factoring also helps us produce rational expressions. For example, if I factor my rational expression with only variables, I'm left with x minus 4 on the top. the bottom I have a difference of two squares, which factors into x minus 4 times x plus 4. I can see that I have an x minus 4 in common, which means they're going to cancel to 1. Divide by x plus 4. We can do the same thing looking at trigonometric rational expressions. Cosine squared of x minus 4 is very similar to saying x squared minus 4. Now this would factor into x minus 2, x plus 2. Cosine squared minus 4 is going to factor into cosine of x minus 2 and cosine of x plus 2. And I added some extra parentheses to the inside of things, which makes things not work out so well. Because I thought I had made a mistake earlier, but that wasn't the case. I have a cosine of x minus 2 and a cosine of x minus 2. Divide those, I get 1, leaving me with a cosine of x plus 2. Sometimes I'm going to have to combine what I know about algebra with what I know about my basic trigonometric identities. Let's begin by looking at the numerator here. Sine squared of y is the same thing based on my Pythagorean identities as saying 1 minus cosine squared of y. I'm going to leave the 1 minus cosine y for now. If I factor the numerator by difference of two squares, I get 1 minus cosine y times 1 plus cosine y, all divided by 1 minus cosine y. Just like the last example, we can see that we have two of the same term. Those are going to cancel with 1, leaving me with 1 plus cosine of y.